planning and analysis. So the agenda for the day, we just give a little time. Well, we were going to have a little tiny review of workshop 1. Basically, but what I will do is I'll just bring you up to date regarding what we're planning for the next 2 workshops. We'll then spend about 40 minutes talking about developing site analysis and planning. So we're going to talk a little bit about site analysis and the constraints of the site. We're going to talk about, we're going to look at the amenities of the kinds of things that we need to require. We're going to talk a little bit about a sustainable environment, and then we're also going to talk about green sustainable resources. So, and then we'll conclude with a 10-minute Q&A. So there is a video. There is a video which I will create. There won't be a SketchUp file. We're actually saving that for next week. Okay. Right. Okay. So where are we? Last week I used to thank everybody who attended the workshop 1 at the University of London. Looking to the future, right now I'm actually in discussions with University of Westminster. The issue that we've got, I think quite a lot of the people who actually came to the workshop on the 7th of March that came on the 16th of February would have issues actually attending the workshop that we had initially planned for the 9th of March. So what I've been trying to do is to speak with Westminster to see if we can actually bring it forward to either the 7th of March or the 8th of March. So one of the 2 options that we have is to deliver either at Westminster or even at back at University of East London again. And the option is that we will just do a half-day workshop on the 7th of March, or the other option that we might do a full-day workshop and we'll also include what we're planning for workshop 3 at the same time. So as I say, unfortunately, I was hoping to have that concluded by now, but that hasn't happened. So where are we? So what happens is that regarding the webinars, we've now completed the concept phases of the webinars, which has taken us from site appraisals, SketchUp in a nutshell, and right the way through to layout book to present the concept scheme. What we're going to be doing in phase 2, which is what we classify as the development phase. So we're going to today again is literally just going through some of the concept ideas and the principles that we need to consider when we're actually planning a site. And then what happens is that we'll do some development work in SketchUp of how we would develop a master plan, how we would import a model. We'll also be then looking at fundamentals such as Saphira, of how we use Saphira to carry out sunlight analysis. And then the final 2 workshops, so webinars that we'll do on the 23rd of March, on the 30th of March, is to conclude SketchUp by looking at how we create a 3D animation, and then finally we will go back to the layout book again to show how we can actually create our final presentation. So when we are looking at a site, there are several things that we need to think about. We need to think about site analysis and the constraints of the site itself. So we also need to consider such things as site amenities. What is close by? How can we actually access the site? And from not just from a when we actually sort of live there, it literally is how we can actually what constraints have we got regarding the site when we're actually talking about developing our scheme. So we need to think about things of how we're going to create a sustainable environment, and we also need to consider what green sustainable resources that we're going to use in order to formulate that site. So the site itself for site A, is just south of the just north of the North Woolwich Road. On the site itself is an existing silo building, but if we look at the vicinity within the site and we put a radius around the site here of 600 meters, you can actually evaluate of actually what is within technically a 10-minute walk of the site itself. So you can see that we have pontoon dock tube station. So it's the DLR, it's the overhead railway. We have to the west of the site. So north is at the top, south is at the bottom, east is where we have the pontoon dock, and the west you can see that there is Brittany Village Primary School. And there are other sports facilities around the place. So as a site, it seems to be fairly well resourced to actually maintain the community. And so when we start looking at the site itself, we need to consider really as to how the sun sets and rises. So the factor is when we are creating building, we want to make sure that we're not putting buildings into a lot of shade. We need to consider really how we can actually access the site, what buildings are of historic interest, and so our analysis starts to work from there. Once we have those kind of things, we can then start to look at the site in a little bit more detail. So the site itself is somewhere in the region of about 2.5 hectares. What happens is at the moment is that within the site itself, we have the existing Silo D building. We have a canal that feeds that Silo D, and there are a series of access roads and paths within the site itself. So what's happening is that you can see from the color coding I put on the screen, we've actually divided this up into 4 clear areas. So we've got site A, site B, C, and D. So within each of those 4 zones, we do have the canal, and what we have to the south of the site, we actually have a highway. Now the issue that we've got is that because of the embankment we have between the site and the road itself, we need to consider how we will actually access the road for when we start developing the site for our housing scheme. But there are criteria of things that we need to think of. First of all, we need to establish is what is the size of the homes that we need to put on the site itself. So if we're looking at a design for a single person, we'll want to be looking at somewhere in the region of about 60 square meters. And for a small family home, we want to be looking at a minimum of 100 square meters. When we're planning out the site itself, we need to think about, well, is that we don't want to fill the site with buildings. We need to consider that what's going to happen is 25% of the surface area is only going to be used for housing. The rest of it is going to be used for access roads, green spaces, and spaces that we can use within the community. But probably the most important thing that we need to think about, this site is right next to the water, so we need to consider what's going to happen when we build this site regarding flooding, and the safety of the community that are going to live there. So what happens is that analysis of flood risks are available by going on to Thames Waterside. You can actually pull up an analysis, and it tells you and it highlights exactly where the where the area of flooding is going to be. So if you consider how does this site sit, here we have the Millennium Dome. We have the river winding its way from the city out to the coast, and then we have the Royal Docks, which are accessed from the east side through this little canal bridge. There's a little tiny road link over the top, and here is our site area that we have. And we also have the overhead railway that's linking the various overhead railway lines going down towards London Airport and onto East London University. And so consequently what happens is, when we're looking at the flood risk, is that there are areas which are identified where flooding will rise. Now, at the moment, I think the current plan for flooding is about 30 years, and they are considering flooding rising up to 3 meters. Now, the issue that we have with global warming is the factor is that even though that close by we have the Thames barrage, they are now even consider raising that, because the concerns from a long-term point of view regarding more potential flooding within the vicinity of the River Thames. This is not just happening here in London. It is happening throughout the whole of the UK, as you all would have noticed from the recent news regarding the problem that we're having regarding these storms, and the factor is that what's happening regarding the winds, and the factor is that what happens is we are now having more tidal surges. So we have to be very much mindful as to, when we're viewing a site, as the kind of constraints that we wish to consider. So one of the other things that we need to do is to consider that during the build phase of the site, what can we do? How can we actually minimize the impact on the environment? So rather than the factors that we need to bring construction vehicles to the site itself. So what happens is, so along here is the DLR. Here is the main road, and what happens is, between the road and the south itself, there is quite a high embankment. So it's not feasible to cut a hole in the side there and bring site vehicles from the road. So the only option that we're going to have to do is to actually bring it up this road and bring it in from the north of the site itself. That's one option. The other option that we consider is that we build a temporary factory onto the site, and then what we consider is to actually use a barge where all the components can actually be brought to site and assembled, and therefore what happens is we can then have this kind of sustainable rationale where we can use modern methods of construction in order to actually achieve the outcomes for our site. Other things that we really need to actually consider. The factor is that when we are creating the site itself, we need to consider, that how vehicles are going to be parked. We need to consider the walking distances in relationship from the site itself to actually schools and shops. Yeah, but we also need to consider the effect of the sun and the effect of the wind. So what happens is that with this site being south facing, we know that the sun rises here in the east, and throughout the day it gets higher and higher and higher, and then eventually again it begins to set in the west. Obviously what happens is, between summer and winter we have much different kind of sun profiles. So by using programs like Saphira, we can actually model up the site itself very basically, and then actually carry out what we classify as a sun study to actually understand what the effectors are of the buildings regarding how we actually lay the site itself out. The good thing about this site is the factor is that it is actually it's not an exposed site. So as far as winds, I know that a lot of you would have experienced lots of high winds over the last 2 months, and particularly in London last week. But the factor is and the vast majority of the winds that we get do come from the west. Occasionally we get them. If we get a wind from the south, it tends to be warmer. If it's coming from the north, it tends to be a lot colder. But a lot of our trade winds that we get very, very much, probably some in the region, about 75% of the wind that we get comes from the west itself. So everything is coming from this side. So we need to think about the orientation of our buildings. The factor is that that when we are siting our building on the site, exactly where they will be positioned. When we start looking at flood defences, again, what happens is I've taken a section through the site itself. You can see that we have the elements indicate where the sun is rising and setting, but I've also done a prediction. The factor is that probably this lower illustration probably shows it better, whereas our high water time line of the water it is actually about 1 meter below the level of the ground. But if we start predicting 1 meter, 2, 3 or 4 meter flooding, you can see that what happens is we now need to start considering is that these pieces of land that we have within the site are going to have to be actually raised. Now what happens is that we can put that to a lot of advantages. So by the factor is that we could actually build a fortification kind of structure around the site itself. We can use the ground and so we might consider building up the site about 2 meters, perhaps 3 meters, and therefore what happens is that we can use the land actually underground as for car parking. We can use the level of the ground below our houses for storing water. So the factor is that one of the things that happens is where you have a green site is that when it rains is a lot of that water gets absorbed and it slowly sort of runs off into the water courses. Once you start building on the site itself, suddenly what happens is the water runoff is actually a lot faster. So, and there are things that we can do. So we can consider actually having a sustainable water system, whereas by putting tanks into the ground itself, we can capture that water itself. We can actually fit it with a control valve, and so the factor is that the tanks themselves can actually hold the water. But what happens is the release of that water into the water course is actually controlled to a lot better degree. There are other things that we can do to supplement the water runoff. So the factors by having green roofs within our building, again, what happens is by having these kind of softer kind of surfaces, is that we can again slow down the runoff. And so consequently, from an environmental point of view, we can actually think about all these things. Other things that we can do is obviously plant trees, put more greenery onto the site itself. So this little sketch here is actually showing how I have sort of laid this site out. So what happens is that I've created a series of 60 square meters homes, which are very, very much classified as a single person home. Therefore what I've done is I've considered that what we're going to have is somewhere in the region of probably about 20 of those single person homes. Each of those is about 60 square meters. We're then going to have a series of 2-3 bedroom family homes, which are 2-story. They can be created to actually sit over the top of them. So we're actually creating a three kind of story building. We can consider things such as inverted living, where we actually have the bedrooms on the lower floor and the living space actually on the top floor. What inverted living allows us to do is that when we are designing a house itself, is the factor is that we need to think of things as how warm the building is going to be. And so the fact is, we all know that heat rises. So therefore what happens is, if we're only heating the bedrooms, which are actually on the lower floor, the heat will rise. So therefore the amount of secondary heating that we require to heat the upper floors are actually less. We can then rely a little bit more regarding natural solar heating to heat the buildings up. So suddenly what happens is we are creating a home which is a lot more sustainable from that point of view, just by going through that kind of process. And then the other thing that we've got mixed within the house is what I've classified is there are 8 3/4 bedroom family homes. So they can be 2-story, they could be 3-story. So for my initial planning for the site itself, I've kept most of those houses using a modular system of modules 5 meters by 10 meters, and I have assembled those in various ways. One of the constraints that we need to think regarding the site itself is to the factor as well. What do we do regarding parking? How much parking do we need to create? The government legislation states that we ought to create 1.5 parking spaces per dwelling. Now, when you have a sustainable society such as what we're looking to actually create this site, is that we have a little bit more flexibility. So we can start considering having things such as car share. We can consider things that fact as well. Well, where is public transport within our site? How far do you have to go? Well, we've already identified that from the earlier slides, that really in a lot of sense is that we have good public transport within 10 minutes of the site itself. And so what happens is that we can now start creating more use of the green space. So, and if you look at the illustrations, what I've done, I've created some community gardens. I've created one to the east of the site, and I've created 2 to the west of the site. Other things I've created within the site itself are outdoor play areas. I've considered the factors that I'm utilizing this existing track that runs through to make that more of a cycle jogging path, and that will run the full length of the site itself. Within the lower area, we have the existing silo building. Now we can think about what's going to happen to that building itself. It's a grade 2 listed building, so we can't just knock it down, but we can actually consider using it for other things. So we might consider actually using that building as a community centre, as a space that people can use in order to actually enhance the well-being of people living within the site itself. If you think about it, what have we got here? Potentially, we have somewhere in the region of 20 single-person homes, 20 3-bedroom homes, and we have 8 family homes. So altogether, we've got about 50 homes on here. if you take an average of 3 people per home on there, and so consequently you're going to have about 150, perhaps even 200 people living within this community. So there are things that we want to consider, and so the factor is that how we formulate the site and how we lay the site out is part of the whole process. But what goes with this is the factor is that what green sustainable resources can we use? There's a big push at the moment from this government for any new housing built from 2025 not to have gas central heating. Personally, I think it is a ridiculous situation, because what they are pushing in their place is these things called air source heat pumps. Now, an air source heat pump, in my mind, is nothing but an outdoor air conditioning unit. So the fact is, okay, where you have houses which have their own gardens and space, you could conceivably say, yeah, that's a viable option. Obviously, the reason why they are moving along that particular line is the factor is that what the heat pumps are is that they are using solar energy, they're using wind energy, they're using ground source energy in order to actually generate a heating system that can be used within the property itself. And so consequently what happens is technically you say, well, there are no emissions to it. The downside behind using air source heat pumps is if you happen to live in an apartment that doesn't happen to have a garden, that happens to be higher than 3 stories, you literally are going. It's impossible. It will not work. So the factor is, how do you maintain them? And the factor is that if you consider is that if they're poorly maintained, what's going to happen is in 4 or 5 years' time of them being installed, you are going to have a noise problem. So you can imagine that you're going to hear these motors running throughout the night, particularly in the winter time, where you actually requiring more heat. And so really, in essence, it's a political process rather than a practical process. But there are alternatives. I'll try and finish on this. I'm finishing today's workshop on a presentation regarding hydrogen in the homes, of how we can actually use hydrogen to replace the gas. And the factor is that what it does, again, it is because it's hydrogen, it has zero carbon emissions. Cost wise, it's not as costly as air source heat pumps, but at the same time, it is new technology. It's where we are going. So back to the kind of constraints. So when we're looking at the site itself, we're looking at the sunlight. We need to consider the direction of the sun. We need to consider how the site's going to be laid out regarding parking and transport, and we need to consider what sustainable resources we're going to use. I talked earlier on regarding in the first workshop webinar that we did. We talked about the Disability Inequality Act 2010, and the factor is that when we are creating homes for the future, I mean this act is 2010, so this is 12 years old, so this isn't new stuff. The issue is that very few developers are actually using it, and the DDA regulators are finding it very, very frustrating. But there are key elements of the kind of things that we need to consider. So when we are creating a house for a future, we need to consider that it has a level entrance point, and it needs to have an area that is clear of any obstructions. We need to consider minimum door clearances. So we need to have a door clearance, not a door width, because the width of the door is wider than what the clearance will be. But so we need to go for an 860mm clearance. This is so that people who happen to be in a wheelchair can actually use the property with unaided. Other things that we need to consider of the factor is that we need to have contrasting colours that define openings. I was speaking to a young lady the other day. She's 28-year-old. 7 years ago, she actually suffered a brain seizure. And here she is now, is that she's starting to lose the sight in her eyes. She's already fallen down the stairs a couple of times. She can't find she can't identify where doorways start and finish because they're all painted the same colour. And so by having a contrasting colour, it makes it easier for people who have a disability of one form or another. Other things that we need to think about is turning spaces. So all rooms need to consider that when if you are in a wheelchair, you need to consider that you're making the rooms big enough that a wheelchair can actually turn around within a 1.5 meter diameter space. Socket heights need to be considered. So no lower than 600mm, no higher than actually 1.2. The staircases, we need to consider the stairs that we have within our homes have no more than 170mm rise, and they've got a going of 250mm. The issue is that the reason why we have these regulations is the fact is we're not creating every house for disabled people in mind. We are designing a house for a house to be sustainable. So as we get older, as we as for illnesses, accidents, or whatever happens to us, is that we can still live within our home. It's our environment, it's where we are. And so these are not great things that we do. It doesn't add any more to the cost of the house itself. And the factor is that by having these careful considerations of how we use the space itself, we can actually be inclusive in the way that we think. The definitions for disabled people is someone who's got a physical impairment that limits their ability to walk. So it doesn't need me to say that they are in a wheelchair. Yes, obviously there are people who are dependent upon wheelchairs for mobility, people who have got impaired sight, and people who have got impaired hearing. There are just 4 of the most common ones, but we also can start thinking about people who have actually got dementia, and the kinds of things that we can do in order to actually make them feel safe and still stay within their home. But that's another subject. So before we start working on our designs for our homes, we need to think about the spaces that we are creating. So we need to think the factor is that where we have an entrance hall, we need to consider that space, that entrance hall, needs to be a minimum of 1.2 meters wide. We need to think about when we are creating a bathroom, and so a standard bathroom in order to meet those requirements. Whereas a person can use the bathroom, they can have a wheelchair that turns within that space. You are looking at a space for a bathroom somewhere in the region about 2.4 meters by 2.1 meters. And so I'm sure that if a lot of you look at your own bathrooms, you think, my word, I don't think we're big enough. Likewise, the same as bedrooms. The factor is that when we are thinking of a bedroom, is again, this is minimum space. So in essence, that we want to have a space where we have a bed where potentially there could be room on one side up to 900 millimeters wide, but we need a space on the other side and at the end of the bed to be about 1.5 meters wide. And likewise, when you come into the room, we need to consider the width of the door, the direction of the door opening. And so the factor is, by thinking of these kind of criteria, is of how much space do we need to actually consider within the design of our house itself. And so the factor is that when we are considering the space itself, and we start thinking about how that would articulate itself into a modular format, is the factor is that how could we actually develop our ideas. And so the factor is, before we start going into any kind of 3D modeling process, we can actually sort of define exactly what we're doing. So other things that we need to think about is inspirational ideas. The factor is that there are some really, really good examples out there that we can actually think about. So you look at my little tiny sketches that I've just done. Where's it come from? Here we have this is design student accommodation for the Dyson Institute. So each of these modules were designed as a self-accommodation for the students that will occupy the site itself. They've been designed so that they can be stacked upon one another, and so each one is actually given its unique individual space. The orientation regarding those buildings are all set so that they have their private outdoor space, and the factor is that they are set back so that what happens is that they are maximizing the light, but they are actually reducing the amount of heat gains that you come into the building itself. Other schemes that we can consider, the factor is actually having houses which are actually on stilts. So the factor is that what happens is the ground floor space itself can be used for car parking. It can also be used for as a workshop for people to work from home. And so the factor is that we have in this community where we can have various artisans who work within the community who can actually support the community. Here is another scheme where we have the houses surrounded around this common area. There are no vehicles within there. This is purely for recreation spaces. So there are cycleways, there are play courts within there, there are community allotments within the space itself. And so what happens is we are creating this kind of community where people feel, you can feel safe within the space, within that area. And when we are thinking about a community, people want to feel safe. And then, of course, we have, that how small can we go? What is the smallest unit that we can create? This illustration is showing a 2.7 meter cube that was designed by Professor Richard Horden. These were designed initially to actually investigate the actual kind of living space. How small an area can we be? Okay, 2.7 meter cube is not a big space, but potentially we can actually add these as add-on modules to our house. So the factor is, by creating a module that's say only 60 square meters, by having an offsite module that can actually be appended to the building itself, suddenly is given that little bit more space. It's giving, it's making it affordable. It's putting it into a process where people can actually work within their homes. We see a lot of these home gardens actually appearing. One of the things that's come very much from the lockdown is that kind of process. And so it leads me to an important piece of reading. A gentleman called Victor Papanek, Professor Papanek. He brought a book out in 1995 called The Green Imperative. It was actually republished literally last year, which I was so pleased about, because what the Green Imperative talks about, it talks about sustainability. It talks about the kind of homes and the environment that we live in. But there's one chapter which I'm going to highlight a little bit, which is chapter 9. It's called Sharing, Not Buying. We're in a consumer society where literally that we all have our own appliances. We'll have our own washing machine, we'll have our own dishwasher, we'll have our own TV, we'll have our own mobile phone, we'll have our own computer, we'll have all our own things, we'll have our own cars, we'll have our own bicycles. But what's coming from this is what's classified as a disposable society. What happens to them when they sort of get out of date? You can probably find, you go around your own homes and see how many appliances that you have in your own home that you haven't used for years. What do you do with them? And so what Victor Papanek was thinking about is the fact is that why can't we consider that when we create our communities is actually having areas where people can share? And so one of the examples that is highlighted within the book is what was classified as a neighbourhood playground. Now, when the neighbourhood playground was first created, is that what happened is that people weren't using it because the factor is that people were had concerns regarding the safety of their children. That they weren't keen on allowing their children just to go out and play and to actually go to this community space. So they had this idea. What happens is if we create this little tiny greenhouse and a little tiny outbuilding, and we put in there a series of washing machines. So what happens is that we have a space where literally it's like we have our own little private laundrette. So rather than having our own washing machines, is that we can use the space for actually for carrying out our daily chores or our weekly chores or monthly chores, what I happen to be. But what they found out is that when they reviewed the scheme 12 years later, what emerged on that site was what's classified a greenhouse group. What that greenhouse group were doing is that they provide a focal point for the community. And so the factor is that they were using that community, what the community were doing. They were not only were they, the factor is instead of everybody having a car, they would have a community car. They would have community bicycles. They would have a situation where they would use the space and grow things together. So the factor is whether you're young, whether you're old, people were suddenly using this as a community space. But what came from this was even more, is that the factor is that they were creating it for focus groups, for shared groups, for health groups. So I've put the ISBN reference onto there. I think the book itself is not expensive. It's around about £9 from Amazon. So it is a good read. And I think the factor is that when we start talking about sustainability, the Green Imperative actually covers a lot of salient points that we have forgotten about. And I think when we're looking at the community, it's something to actually consider. Just going to wrap up with a few little highlights regarding what we classify as sustainable processes. So when we are looking at sustainable processes, we can carry out things. We can embed things within the scheme itself. So, a sedum roof. What's sedum? Sedum is a plant. It doesn't. It literally. They grow in areas which don't require much rainfall. So the factor is that what happens to them is that they do two things. They evaporate the water when water runs onto it, and so what happens is that we can then reduce the amount of water runoff from the roof itself. Having a green roof onto a building, it absorbs carbon, so it's absorbing carbon from the atmosphere. And so sedum roofs are a positive way of going forward. Other things that go with this now is siphonic drainage. What siphonic drainage does, it actually gathers the water that runs off our roofs. It goes into a gravity system. So what it does, it can actually control how much water is actually running off. And so consequently, we can actually use that water for rainwater harvesting. And so there are certain things that we can do with that water. We can collect it, we can put it into a tank, we can put the tank into the ground. So that tank therefore can be used in two ways. The first way that the tank could be used is for gathering water that we can use to water our plants, like a very large rainwater barrel. But what we could also do, we can actually put filters into it. We can put charcoal filters into it. So by filtering the water through from the container, we can then use that water to actually make it palatable. And so the fact is, by putting a UV filter within that, suddenly that the water that we are gathering can be used for washing and for cleaning and for bathing. So by considering something as small as a 3,000 litre tank, prefabricated tank, that's located within the building itself, it can be laid within the site itself, and then what happens is any excess water itself that comes from the tank. In 2020, the European Commission spent 1.5 million to actually fund city trees across various European cities. The idea behind it was to create a carbon capture using moss walls. So I've included the link on the top for the moss walls. I've also added an illustration which explains a little bit about it. So hopefully that will give you a little bit of inspiration as to what moss can do and how we can start incorporating this into our buildings and our designs in order to actually carbon capture. And here's a little tiny video which is created by Carbon Dynamics for the homegrown Scottish using Scottish timber. The video is about 3 minutes long, and it tells you a little bit about off-site construction and the methodologies which are applied. And finally, just to talk a little bit about how we are changing our attitude regarding the systems that we can use to actually heat our homes and to actually create a zero carbon home. At the moment, obviously, there's an awful lot of legislation regarding by the government to try and enforce the use of heat pumps on in replacement for gas central heating. And so the government has actually decreed by 2025 no new homes will actually be built using gas central heating systems. My opinion that this is a bit short-sighted when the fact is the alternative which they are suggesting, which are air source heat pumps, are the only game player in town, according to the government, which is actually far from the truth itself. So this little video actually takes you through what Northern Gasworks are actually doing to actually create hydrogen homes. What's happening is they've actually created a research site which was actually opened 2 years ago. They are about to actually go live to create to put hydrogen into 2,000 homes just outside Newcastle. They've also got a 5-year plan to expand the system into cities such as Leeds and other cities around the UK itself. So it does offer us a viable option. Whereas the issue with ground source heat pumps is fine if you happen to be in a ground floor flat, but if you happen to be on a fourth floor, fifth floor apartment, well, it's rather impractical. Hey ho! But look, let me play the video and let you make your minds up as to what you think about it. But certainly, I've had a look around these hydrogen homes, and I personally think it's a good, viable proposition.
The UK energy sector is facing a time of unprecedented change. With growing populations, rising bills, and our desire for greater flexibility in the way we heat our homes and power our vehicles, it is a fast evolving landscape. But there are also significant challenges ahead. The Climate Change Act requires an 80% reduction in carbon emissions from 1990 levels by the year 2050. And this forms just one part of the energy trilemma, a formidable conundrum.
What we're trying to do is solve 3 really difficult problems simultaneously. That's how to have an energy system that is secure, affordable, and also sustainable, and i.e. low carbon. Now, trying to solve one of those problems at a time would be difficult, but trying to solve all 3 together is incredibly difficult. It's one of these problems people call a wicked problem, a wicked challenge.
Increasingly, both industry and academia believe that this challenge can be best addressed through collaboration by the UK's different energy systems, gas, electricity, renewables and transport, working together.
If we do what has been done for previous decades, which is look at just one aspect of the energy system at a time, then we don't really see the whole picture. So what we're trying to do is take a whole systems approach that discovers the insights around the interdependency between different aspects of the energy system.
Traditionally, we ran an electricity network, and we ran a gas network, and we had a transport system. I think we all owe a duty to get that system working together in a holistic fashion, in a way that delivers the best value for customers, but also delivers the social and environmental outcomes we want.
To facilitate this, Northern Gas Networks, working in partnership with Northern Power Grid and Newcastle University, has created Integral, the UK's first whole energy systems research, development and demonstration facility. The Integral site will provide a testing ground to help understand interdependencies between heating, cooling, transport, gas and electricity, and how we can combine existing infrastructure to deliver clean, affordable energy solutions that meet future demand.
The Integral initiative is really about bringing gas, electricity, academia, small businesses together in quite a unique way that hasn't really been undertaken in the UK before. If we bring the 2 energy sources together, then we've probably got a great solution to decarbonise the UK.
The integral site will include multiple energy generation, conversion and storage technologies on site, which can be combined to test new whole system strategies. A future transport zone will trial whole systems energy support for ultra-low emissions vehicles of the future. A customer energy village, connected to a flexible, controllable gas, electricity and heat network, will provide a testing area for novel domestic energy solutions. And the facility will also house an innovation and engagement hub for businesses and academics, as well as education and engagement with stakeholders and the public.
We're building a joint control room which sees both the electricity system and the gas system together, and then it will allow us to trade between the two, all in real time, and develop the software and the techniques to optimise across quite a complicated system.
Based in Gateshead at a working gas site once used for research, Integral has the capability for testing at full scale, supported by utilities, academic institutions and business interests.
Integral is perfectly positioned on our network, perfectly positioned as well in terms of the electricity network, because we have a high voltage system running onto the site, and it's a great location for small businesses, academia to get involved in.
Integral plays very much to the strengths of the North East. You know, we are a region that has a great energy history. We have the skills base, we have a research base, we have a business base that works in this area, and in that context Integral is really welcome.
Well, Newcastle University is a unique place. We have a long heritage of carrying out energy systems research. We also leverage our fantastic deep and long-term partnerships with industry, which allows us to make sure that our research is relevant, is adopted and becomes business as usual.
We have lots of countries looking at the UK to say, how do they copy and learn from what we're doing? And so if we get this right, there is a huge opportunity to create amazing outcomes for UK energy users, but also economically for UK PLC.
So we really want Integral to be an open site. We want it to be perceived as a national asset. We want it to be a place where people come and collaborate. So what we'd like is for industry to come and contact us, invest in the site, work with us on the site and tackle these difficult challenges together.
I think that the two most obvious ways for collaboration for us will be, in the first instance, being able to channel some of the partners that we work with, the innovators that we work with, into the capacity that Integral provides so that it can be tested and developed there. But another thing is making sure that we act as an amplifier, as a communications channel. We leverage the learning to support innovators and innovation in the UK, but also be able to use it, ideally, to open up some international opportunities as well.
Ultimately, Integral aims to test the viability of an integrated whole energy system that could cost a fraction of the alternatives, saving customers money and disruption whilst addressing the huge future energy challenges we face.
None of us have all the solutions, so the vision here is we come together collaboratively and we work together. So we run the electricity network and the gas network back to back, mutually supportive, and it's that collaboration that's the heart of the Integral project.
I think its uniqueness is because we are very, very open about what we're trying to achieve here, and that can only be a benefit to the customer, because if we look at these things singularly, then there's going to be an incremental cost for each of those. If we can look at working those systems between ourselves, I think there'll be a huge customer benefit.
So just to conclude, I've included the links to the various websites. The next webinar is on the 2nd of March, and we'll be using SKETCHUP for that webinar, and we're looking at developing the master plan and looking at model import. Thank you all very, very much for attending today, and I look forward to seeing you on the 2nd of March, and obviously that hopefully that you'll be able to attend the next workshops, which are going to be on the 7th/8th of March, but that was to be determined hopefully this week, and obviously you'll be informed. Thank you all very much for attending, and look forward to seeing you next week. Thank you so much. Bye bye.